Frazee, and this is the video tutorial to model the S60-125 rocker arm. Okay, this part is symmetrical. We want to think about design intent. It's a rocker arm, so it's moving something up and down. Looks like it's proportionally symmetrical. We have 3 high tolerance holes, and the rest of the holes are what are called lightning holes to just lighten the part. There are multiple ways to address this. Some people like to do everything in a sketch on something like this and do one extrusion. I'm going to show you a different method so that you can learn 2 different mirroring commands. So bear with me on this. Please follow the process that I'm showing. So what we're going to do is we're going to start off with the outside profile. And we're going to keep it simple and we're going to mirror that. Then we're going to do the set of holes that are mirrored as what are called model features. And so that uses a different level of mirroring in the software. And that way you learn both and the pros and cons of that. Okay, so let's start. We want to draw basically the left side of the outside profile. Let's contain it to that. That way we can move in baby steps, chunks. Okay, so what we're going to do is we're going to go to SolidWorks and open a file, but we're going to start off with our design intent with this hole being on origin. Okay, so we're going to start, and we're going to start on a plane. We're going to trace a left line, a vertical line, a angled line, a vertical line, a horizontal line, an arc, and then another diagonal line back to origin. So let's do that. We're going to go to SolidWorks. We're going to make a new part file. Make sure you save it off in the proper convention. So this is the S60-125 with your revision. Okay, we're going to go to sketch, and we're going to do a sketch, and we're going to sketch on the front plane. We're going to start with doing 2 center lines. First one is going to go from origin up. We want to make sure it's constrained vertical. And then we're going to do another center line from origin to the left. And we're going to make sure that's constrained horizontally. For simplicity, I want you to click on each one of those and make them infinitely long. Okay? That way we don't have to deal with endpoints being unconstrained. Okay, now we're going to take a line, and we're going to go from the vertical center line above origin, and we want to make sure that yellow icon is highlighted so that we're getting an automatic relation. We're going to go horizontal, then we're going to go vertical, then we're going to intentionally make an angle, then we're going to go straight down, we're going to go across, and now we want a non-tangent arc, so this might be a challenge, but that's how you do it. And we want to drag the endpoint to below the center line. And then we're going to go back to the center, but we don't want to constrain it horizontal. So you should have this kind of boat looking shape when you're done. Now, this arc can be a little tricky sometimes. It's supposed to be tangent here, but not tangent at this line. So let's highlight the diagonal line and the arc, and let's make them tangent. Okay. Now we have our basic shape. Let's look at how this is constrained. Okay, so we're going to start from origin, and we're going to anchor everything. We're going to try to go from right to left and see how this goes. Okay, so you may have drawn yours in scale a different shape, but don't move any farther forward until you have a shape that looks like this. And I just noticed one thing. I have an unintended relationship here. The center of this arc is not supposed to be centered on this line. So I'm going to delete that relationship. I'm going to drag the line up, and that's reflective of how this part's supposed to look. Okay, so the center of this arc should not be aligned with anything at this point. Okay, so get your shape looking like this before you move forward. Okay, and you want this line to be above the horizontal center line and this below. Okay, all right, so we're going to anchor our dimensions on the right hand side. Okay, you might have different dimensions. So let's look at our drawing of what the dimension difference between this line and the horizontal center line is. We go to our drawing and it's 100 thousandths, so 0.1 right here. So that is the distance between this edge and the center line. That's what we're representing here. And so we're going to make a dimension line from horizontal line to center line. And we're going to click and we're going to put 0.1. And hopefully your view will auto scale like mine did. If it doesn't and things go haywire, just drag stuff back to where it looks proportionally right. Okay, we're going to hit accept. And then we're going to do the dimension between this endpoint I have highlighted here on the diagonal line to origin. So it's going to go from here to the center line. We're going to click and we're going to look at our drawing, and it is this 200 thousandths dimension here on the right. Not sure why it's called 2 times. It isn't necessarily needed to be called 2 times. So anyway, it's 200 thousandths. So we're going to put in 0.2. Alright, so now we've anchored the width of this. Proportion wise, this should be kind of close to what the finished product's going to be. Okay, the next thing I want to do is we're going to anchor this arc. It's problematic when it goes crazy. So we're going to put, first thing we're going to do is you want center line, or so center of the arc to be aligned with the center line of the part of the horizontal center line. We want to make that coincident. So again, you're going to highlight the center of the arc, hold the shift key down, and then select the center line, or vice versa. And we're going to tie that arc to the horizontal center line. Again, this end should not be tangent, and this side should be tangent. And this line is not in the same plane as the center line. So stop and fix that if you still have that set up that way. Alright, our next feature. We're going to, again, we're going to dimension this arc. Okay, so we're going to go there and click, and that dimension compared to our drawing is 100 thousandths. So let's put in 0.1. Okay, so that's going to keep that feature fixed in size. And if you have the tangency and the endpoint in the right place, we should be okay there. Alright, now let's keep working on our horizontal relationships. I'm sorry, vertical dimensions. Okay, so we have this established, the 100 thousandths, and we have the 20 thousandths established. Let's go to our next highest point. So we're going to dimension from here to center line, which is how the drawing has it, and click. And let's go to our drawing and find that dimension. The crest of our taper that runs up to this corner is called at 180 thousandths. So let's dimension that. 0.18. Okay, so that gives us our dimension from center line to the peak. Now let's get the other side. That is dimensioned over here at 130 thousandths. Select the center line first and then the point, click, point 130. Okay, so we have now, working from the right to left, we have this angle now established. We don't have the left to right relationship, but we've got from center line, we've established all those dimensions. Now our last one is this flat to center line. So on our drawing, it's over here, from flat to center line is 60 thousandths. Okay, so everything's constrained in that axis. Now let's work on the opposite axis. I'm going to like to go with the longest dimension, but that might be an error. So we shall see how that works. So I'm going to go from the vertical center line to the center of this arc. Okay, and it defaults for me for 800 thousandths, but in our drawing, that distance is from the center of this hole to the center of this hole, which is concentric to this radius. So it is 1 inch 260. And it stretches the entire part out. Okay, now let's work from right to left. So we have the length of this line. Right now we haven't told it how long it is. So right now, if I were to hit escape, this stretches all over the place. So does this one. These are not constrained. We haven't told SolidWorks the size of those features. So let's start off with this one. And we know it's not constrained because it's still blue. We're going to go to our drawing here, and the distance from center line to the vertical edge, which would be the length of this line at this point, is 2 times 240 because we're only drawing half the part. So we want a 240 thousandths dimension. So let's go to our drawing, and we're going to pick the dimension tool. We're going to pick the line we want, 240, so 0.24. It shrinks it up. Okay, at this point that should have turned black, and I didn't understand why, and then I look, and this center line doesn't look like I actually made a relationship with origin, which is a common mistake. So let's fix it now. We've got our vertical line, we're going to hit origin, and we're going to make that coincident. And it looks like I may have the same problem with my horizontal one. So we're going to highlight that center line, highlight origin, and hit coincident. I'm not sure at what point I lost the relationship. It might have been when I made it infinitely long. So now what we see in black is constrained, and what is blue still needs relationships. If you're not sure what it is, grab on things and start pulling on it. Okay, so right now the length of this is not defined. Let's go to dimension. We're going to pick the vertical line, then our vertical center line, and we're going to put in this dimension, which according to our drawing, from this vertical edge here to the center of part is 1 inch 120. Okay, so this should be fully constrained. We have an open profile, which is okay for this type of command. So your sketch shouldn't have a negative symbol. If it does, we need to resolve what is wrong before we proceed. Now we're going to put in the fillets that affect the dimensions. So we're going to use the sketch fillet tool, and according to our drawing, we have an R 200,000 or 20 thousandths in 10 places. So we're going to put those in 5 places. So let's set our fillet size at 0.01, and then we're going to go around, and this is the first place, second place, third place, fourth place, and fifth place. We're now going to hit accept. And our dimensions should have updated to the tangency points. So if they didn't, it shouldn't. And so now we have our fillets. Our sketch should still be constrained. If it's not, you need to fix it before you proceed. Okay, so now we're going to use this sketch mirror image. You want to make sure this is all fully constrained because any errors you have here are going to be duplicated when you do this. We're going to select what we're going to mirror, which is everything except for our center line. If you get something you don't want, you just pick on them and it will deselect. And then we're going to copy about the vertical line. And you should get a preview that looks like this. We're going to hit accept. And if you did everything right, it should be solid shaded. Errors I see that students do, they put a solid line in between here. Fusion allows you to do that, SolidWorks does not. SolidWorks is going to interpret that different. It's going to say, I can't make an infinitely thin cross section there. So it's just a different way the software works. All of these symbols that are now added say we've got symmetry around the center line. So anything you change on one side will change on the other, but you got to be careful because it's really easy to break these relationships. Okay, so now that we have that mirrored, we're going to exit out of this tool. We're going to keep our sketch highlighted. We're going to go to features and we're going to do our extruded base. The thickness of this part is 0.063. Okay, so it's about a 1/16 thick. There we have our thickness, and we're going to hit accept. Okay, now let's save.